Imagine stepping onto a time machine and setting the dial to 50,000 years ago. You land in the Iberian Peninsula, today Spain, Portugal. Two kinds of humans share the land, Neanderthals and people like us, Homo sapiens. What happens next isn't just a single story. It's a moving, shifting web of encounters, retreats, and survival. For the first time, a new numerical simulation from the University of Cologne lets me actually trace those interactions as they unfold over thousands of years. Not just static snapshots, dynamic movement changing populations and shifting opportunities. The study, published in PLOS 1, zooms in on the period between roughly 50,000 and 38,000 years ago. That's when Homo sapiens start arriving in Europe, while Neanderthals are still very much there, coexisting, adapting, and eventually disappearing. The model was led by Professor Yaping Xiao from the Institute of Geophysics and Meteorology as part of the HESCOR project, with archaeologist Gerd Christian Weniger collaborating. So, how do you simulate the past when there are no CCTV cameras, no census data? You start with what we do know, where archaeological sites are, how climates shifted where resources likely clustered, and how groups move when food, water, and shelter change. Then you build rules. Populations grow, populations shrink, groups migrate along rivers, groups migrate along coasts, contact chances rise in key corridors and drop in harsh seasons. Run it forward and patterns appear. The Iberian Peninsula acts like a gateway and a refuge, its mountains and coastline shaping who meets whom and when. In some simulations, Neanderthals hold ground in rugged zones a little longer. In others, early Homo sapiens funnel through resource-rich routes, creating windows of contact. Trading, sharing know-how, maybe competing. Importantly, the model doesn't tell a single, neat story. It maps possibilities. It shows that coexistence could persist for centuries, even millennia, punctuated by pulses of contact enough for cultural exchange, maybe even interbreeding, before demographic tides turn. Why does this matter? Because the why behind Neanderthal disappearance isn't one villain. It's overlapping pressures, climate swings, patchy resources, small population sizes, and the arrival of flexible newcomers who move fast and network widely. This model helps test those ideas together instead of guessing in isolation. And here's the cool part. The same framework can be tweaked for other regions and periods, asking if the landscape looked like this and people moved like that, what histories become likely? It's not a time machine, but it's the next best thing. A way to replay the past with evidence and math. So next time you picture Neanderthals fading into the mist, remember, they didn't just vanish overnight. Their story is a dynamic map of encounters, traced for the first time in motion. And it tells us something about us, too. Survival favors those who adapt, connect, and keep moving.